Hello there, this is Alana Tuckey, lead faculty for Math 133. I've received a question about this problem, which is 2.3.5, which means it's the fifth exercise in section 2.3 from the textbook. So it'll show up in your MyMathLab homework for section 2.3, but of course I can't tell you which problem it'll be because it depends. So it might be question 3, it might be question 4, etc. But you can tell it from the top right corner up here. Now, it has a whole bunch of parts to it, and I'm going to click on View an Example, and we're going to look at the example. So the accompanying frequency polygon shows the number of a country's residents below 100 years of age, completes part A through G, so we got a lot to get through. So I'm going to click on the little icon to view the polygon, and remember you can click on this magnifying glass to make it larger. You can make it normal size, which is what it is right now, medium size, which is a bit bigger, or maximize it and makes it as large as the window behind it. And then it'll ask a whole bunch of questions about it. So what I did was I actually put it into a different document so that we could look at it all at once. So all the questions are in here rather than in MyMathLab. All right, so here's our frequency polygon right here. The first question asks us, what is the class width? Well, the class width is literally how wide apart are the dots for the graph. We'll talk about what the dots are in a minute, but they're the midpoints. So this dot to this dot, how wide apart are they? Well, it's the difference between this number here, which is 5, and this number here, which is 15, or 15 to 25, or 25 to 35. How far apart are they? And that's your class width, which in this case is 10, because 15 take away 5 is 10. Now, how many classes are represented? Well, that's a different question. So there are, now remember, it might at first appear that you should count the dots, except from the notes in section 2.3, we learned that a frequency polygon has a fake starting class and a fake ending class. They're not real, which will have a frequency of 0. So that means that this dot right here at -5 is not really part of this distribution, which makes sense because this is how many people are of a certain age in a country. People cannot be -5 years old. Similarly, the 105 is not real over here. So that's not going to work. So that means we only have to count the dots that are not those two, the beginning and the ending one, which are fake. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 classes represented because the first and the last need to be ignored. There, ignore the fake first and last midpoints. All right, what is the midpoint of the third class? What are the lower and upper class limits of the third class? Assume that lower class and upper class limits are whole numbers. Okay, so -5 is not really a class. So the first class is actually here at 5. That's its midpoint. And the next class is 15. That's its midpoint. And then the third class is 25. So 25 is the midpoint of the third class. Now, why do I know it's 25? Well, recall, a frequency polygon uses the class midpoints on the x-axis. So those numbers that we're seeing on the x-axis are the midpoints. So first dot is the first class, second class, third class. Okay, so now we get to the trickier problem of what was the lower class and upper class limits. So the midpoint of the class ahead of it is 15. And then the midpoint of this class is 25. So the lower class limit will be halfway between 15 and 25, which would be 20, right? You're finding the number that's halfway between 15 and 25. That's the average of 15 and 25, if you will. So you're going to take 15 plus 25, add them up and divide by 2, and you will get 20. Okay, well, if that's the case, what about the upper class limit? Well, that's a little bit trickier to do. So the lower limit of the next class, the fourth class, if you will, would be halfway between 25 and 35. So that would be the lower limit of the next class over. Or if you like, you could say it's 20 plus 10. 20 plus our class width of 10, which would get you 30. Okay, so that would be the lower class limit of the next class. So the upper class limit of the third class would be the number that's right below 30, which would be 29. It's one right below the upper class limit of the next class. Now, if they didn't say whole numbers, you could say 29.9 or 29.99999. But since they say to use whole numbers, we would actually just round it to 29. So I think it'll help if you keep in mind what you're trying to do here. You know what the midpoints are, and what you're trying to do is figure out what these numbers over here in the classes would have been. So we just figured out that this one must have been 20 to 29 because this next one, the fourth class, starts at 30. Because halfway between 15 and 25, these two numbers will get you this number right here, 20. Halfway between 25 and 35 will get you this number, 30, which means this number up here, the upper class limit of the third class, must have been the number right below 30. All right, now what is the midpoint of the last class? Well, the last class is right here at 95, right? Because remember, the 105 doesn't count. So the last class limit is 95. So I just extended my table so you could see it. So the last class limit is 95. Excuse me, class midpoint is 95. Now, what are the lower and upper class limits for those? Okay, well, similarly, the width is how far apart these numbers are, 5 to 15, 15 to 25, and so on. But it's also 20 to 30, and so on. So you could figure it out by just keeping on adding on 40, 50, 50, 60, 70, 80, 90. There it is. But you could also see it because it's the halfway spot between 85 and 95, which would mean that it's 90. Right? So you can either find that by adding on numbers right here, right? Adding on the class width, if you will. So adding on 10, adding on 10, adding on 10, just like we could have done here to get from 20 to 30. You can just add on 10, which by the way means that this must be 10 and this must be 0. Right? Or you can get it by taking the halfway point between 85 and 95, and then it gets you the 90. Now we know the class width is 10, and we can use that fact to help ourselves with the upper class limit, because they want to know the upper class limit, and that would be 99. Now you can tell that because you can say, well, okay, if my class width is 10, then the next class would be 100. For example, I can see the fake midpoint of 105 right here. So the halfway spot between 95 and 105 is 100, so this must be 99 right here, the number that's right below 100. Or you could take 29 and just keep adding on 10. 29 plus your class width of 10 gets you 39, plus your class width of 10 gets you 49, and so on, right? And then you could work your way all the way up to 99. So that's another way to do it. Now remember, this last class doesn't really exist, but that's what it would be, right? If it did exist. There. And again, remember 105 is not truly a midpoint, but it's close enough. Okay, so now let's answer a couple of questions. Which age group has the highest population? Which age group has the lowest population? And estimate the population for each of these age groups. Well, you're going to look at the dots, ignore the -5 and the 105. Highest population would mean it's the highest point. Lowest population would mean the lowest point. And remember that this over here is the population in millions. So you can read the graphs pretty simply for those two questions. So D and E should be very simple. F, on the other hand, we want to estimate the total number of residents. That word total, that's kind of a big deal. So that means that what we want to do is we want to add up all the numbers. So you're going to need to know how high these dots are, well, at least guess them. So for example, this first dot seems to be about at 41, because if this hash mark is 40 and this is 44, then halfway between them is 42, and that dot appears to be 41. So what you're going to do is you're going to say, okay, I want 41 plus, and then you're going to go back up and grab the next dot, which seems to be 41. And then you're going to keep going like that all the way until you get to your last number. And you're going to keep adding and adding and adding, but skip the 105 and the -5, although they're worth 0 anyway. But you're going to try to estimate where each of these dots falls and then add up those numbers. And I'm just going to let you finish that. And then the last thing I want to talk about, between which two classes is the change in population most extreme and least extreme? Change is kind of a big word there. So let's go back and look at the graph. So you can see the changes by how much difference there is between consecutive dots. So they want to know between which two consecutive points was there the biggest change. So let me just take these 2 points right here in the middle. So this one at 35 seems to be at about 42. This one seems to be at about 40. So that's a change of 2, -2 actually, it went down. The negative positive doesn't really matter. And what you're going to look for as you look through this graph is where is that difference between consecutive dots super large, right? The largest it can be, that's the most extreme. And where is it the smallest it can be? That would be the least extreme, right? So the more extreme means more change, less extreme means less change. And I'll let you ponder for a second what it would mean to be the most or the least. And then you can look through these and then find them. And I think it says between which two classes. So it's probably going to be like between the second and third class, or between the third and fourth class, or something like that. Okay, I realize I didn't quite give you the answers for D through G, but I hopefully showed you what to look for. D and E should be pretty simple. You're just looking for specific points. And then F, you're just going to add up all your numbers, your frequencies, if you will. And then for G, you're going to look for where the differences in consecutive classes is greatest and where the difference is smallest.